Okay, so in a previous lesson, we talked about frequency tables. Um, and I made reference to the fact that sometimes you then want to use that frequency table to make a graph. That's what we're going to talking about today. We're going to be talking about representing data graphically. Okay, so graphs are a good visual way to display data, particularly numerical information. All right, but when we've got a graph, what we want to make sure there is a title, because that's what's telling us what the graph is about. We want clear labels on the axes. So what is being shown, it's telling us what's on there. We want the scales, the axes to be evenly scaled. This is especially true when when you've got numerical data, when your data's got, you got numbers there, so you're really clear what's there. And because they need to be consistent and so constant along the length of the axis. You can't chop and change because then it doesn't make sense. Now, when it says legends here, basically the idea that he's saying is if I've got a graph and then I've got 2 bits of data and I use 2 different colors, they have two, that could, that should be this column. What it's basically saying is if I'm, say, talking about braking distance of 2 cars, this would be car 1, this would be car 2. It makes it really clear using different colors, but it's really clear what you're talking about. Okay? Now, the first type of graph we're going to talk about is a column and bar graphs. We're going to focus on a lot on the column graph, and I'll tell you a little bit later what the difference with a bar graph is. They have pretty much mostly the same setups and rules you follow. There's slightly different ways of showing that data. Again, I'll go through that again later. In both, using categories to divide results into groups. The frequency for each category determines the length of the bar or the height of the column. And it is easiest to graph the data from a frequency table because basically when you've got, I'm just going to quickly show a thing here. Remember, you'd have a title, you'd label your axes here. I'm not going to do that for this, just for this quick thing. Generally, this is going to be your frequency along here. This is a frequency, okay? This would be your frequency. So this is where you'd put how high you want it to go up to. So if you've got, your numbers would go up to here. That could represent 5. This, if I'm trying to be reasonably even, again, I'm going to show you a better one of this later. That would be 10. So your frequency from your table is telling you how far up you go. Okay. All right. So here's where we're going to look at column graphs. All right. So here's some rules we need to follow. All right. So it needs to have a title. We need to have a labeled axis, which are clearly and evenly scaled. The columns need to be the same width. There needs to be an even gap between the columns. And the first column beginning half a unit, that is half the column width from the vertical axis. Okay. Now I've got what I've called graph 1 and graph 2. All right. One of these is correct and one of these is incorrect. I'm going to let you think about it for a moment, and I'm going to come back and I'm going to let you know which one's which, and therefore why one's correct and one's not. Okay. So we're back again. All right. Let's have a look. So this one is incorrect, and therefore this one is correct over here. Now, what are the differences? Let's look at what we've got. They've both got titles. That's good. They've both got labeled axes, which are clearly and evenly scaled. So titles, axes, cool. They're both correct there. All the columns are the same width. Now, the correct, as you can see, is 2, 2, 2, and 2 columns across, or two squares across. It doesn't have to be 2 squares. That's what I've done in this case. As you can see here, I've got 2, 2, 2, 1. That's one reason why this one's incorrect. An even gap between each column. Now, we'll skip the first part because we're going to come back. That's in actually number 5 here, 0.5. Now, I've got 2, 1, 2. These aren't consistent. I've got 2, 1, and 2. So I've got 2, 1, and 2. That's not going to work. Whereas this one, remember, has 2, 2, 2. That's the spacing I've used. You've used spacing of 1. That's perfectly fine. You just got to be consistent. Now we get to that 0.5. You could see my columns here are 2. That means this column has to be 1, and it is. So in that part, it's correct. All right. So in this case, Beth surveyed the students in her class to find out preferences for school uniforms. Her results are shown in the table at the right. Construct a column graph to display the results. All right, so what does that mean? So what we're going to need to do here is draw a graph up. So I've got this little graph here. This is something you can do quite easily on graph paper, or if you're using OneNote, you can do this on OneNote. So what's our first thing we need to do? We need a title. What's the title we can do? We're looking at uniforms, preferences. Let's go for uniform preferences. Okay. Now, we want frequency on the side. And down here, and I didn't leave myself a lot of room, we're going to have types of uniforms, okay? Normally you wouldn't put it over here, but yeah, I made a mistake. All right, type of uniform. All right, so what we need to make sure of is, remember, we need things to be, when we've got the numbers, we need our to be evenly spaced. So we've got a top number of 12. So on this axis, on this vertical axis, I need to be able to go up to 12. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can go up in one thing increment. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, now I've got 4 different things here. I'm going to give them a name just because it makes my life a lot easier. WB for white and black, B and B for blue and black, B and N for blue and navy. Normally I wouldn't do this, but just for space considerations, WN for white and navy. Okay, so what that means is, let's do the first one, WB. I'm going to do the same as what I did in my example before. So I'm going to go from here up. So mine are going to be two things across. So I need to go up 8. That's what I've got. So I draw up to 8, then I come down. If you've got a ruler, use a ruler. It makes your life a lot easier. We call that WB. All right. Next one. We're going to go BB. We're going to go up 4. Again, we're going to need 2 spacing, and I'm going to go across 2, up 4 across 2. So that's going to be BB. Then I go BN, so I'm going to have to go up 12. Using a ruler for these long ones makes your life a lot easier, a lot neater too. Call it BN, and WN we want 5. We're going to go up to here, across, and then down. And we'll call that WN. Okay, so that's what you'd need to do in something like this. All right, so bar graphs are drawn in a similar way to column graphs. The big difference is, you know how we had here, the frequency over here. I'm just going to shorthand it and say frequency. And on this side, we had our qualitative type data. So we had Yeah, so that's what you'd have. What happens in a column graph? It gets flipped around. So now the frequency's here, and we have our like uniform preference. So we have the uniform type there. Okay, so we'd have uniform there. So basically you'd go out, like I think we had 8, 4, 12, not very well spaced, I know, etc. And that's where we'd have 12 there. It's basically just flipped onto the side. Okay, same process, except instead of going to vertical, we go horizontal. That's a big difference. Okay, dot plots. So dot plots are, the piece of data is represented by a single dot. Basically, you have that's not very straight. I'll take that as straight enough. Okay, so basically what you have is you've got a line, okay, and then you'd put some numbers on. So you'd start at 0. This depends on the data you've got. I'm just gonna, I'm gonna go up to 10. All right. So what it helps for is I can get a quick overview of distribution. Okay. It shows how things have clustered, extreme values, helps to determine whether the data should be grouped, stuff like that. If a score is repeated, you just put a dot above. And it's a nice visual representation of your data, okay? And important point to make here is you sometimes have something what's called outliers in your data. That means, there's something quite a bit different. It's not typical to the rest of the data, okay? It's like if you've got one tall person and a bunch of, say, sort of shorter people. That taller person is going to be an outlier because it is very different to what everybody else is. Okay, so the example would be if I had, say, as numbers, I've got 0, 1, 1, 5, 7, 9, and 10, and 10. What I need to do is I'd put a 0 there. I might say my 1's roughly there. You'd want to write 1, 2, 3, 4. Oh, I'm going to run out of space. I'll have to do that part again. Oh, and let's draw that again. I think let's quickly draw that again. Okay, so 1, 2, 3, 4, 6, 7, 8, 9, 10. So maybe a bit bigger. Again, these aren't overly everything spaced. I'd be using some sort of graph paper. It makes it a lot neater and a lot easier to understand. Okay, so I'd put a dot there. Oh, sorry, that was I needed to include 0. Oops. I'd put a dot here, and I've got 2 1s. I'd put a dot there. Then I'd put a dot on the 5, then the 7, then the 9, and I've got 2 10s. I mean, I just made a quick show of that data, just show how you put it. You just put it there. If you've got a data, you put it on there. Okay. So here's an example. Over a 2-week period, the number of packets of potato chips sold from a vending machine each day was recorded. Okay. So you're going to draw a line, and you're going to go from, in this case, let's see what we're going to go from. We can go from 8 until 18, because remember, 8 is our smallest number and 18 is our biggest number. So that's what you put on your line. And then as you go across, you read it, you go 10, you'd put a 10 there. You go 8, put an 8, you go 11, put a dot above the 11. Sorry, I missed a 12, then 11, then it's 12, etc., etc., etc. Okay? That is what you're doing with a dot plot. You put the line and you put a dot above it. Okay. So the B says it comments on the distribution. So what you can see is you can look at you can get the range. You're going from 8 to 18. Your range is 10. Most of the data is between, sort of here. That's where most of the data is. All right. These sort of more outlier ones between 8 and 18, not much sold up there. So if you had 20 packets of chips each day, you're pretty much going to be covered in terms of trying to make sure you've got enough chips in the vending machine so you don't run out. That's how you can use that data. Okay, stem and leaf plot. So when a data is being displayed, the stem and leaf plot may be used as an alternative to the frequency distribution table. Okay, so instead of putting a table, you can put in the stem and leaf plot. Or if you hear the term stem plot, same thing. In this case, each piece of data in a stem plot is made up of two components, a stem and a leaf. So in this case, what we're going to do is, for something like 28, the tens component becomes the stem. The unit part becomes the leaf. Okay? So in that case, we'd write 2 and 8. All right? So how we would write that is, we'd say the key for this would be the key, okay, would be, you use an example, you go 2, you put a line there, you go 8 equals 28, okay? If you had a number like 323, what would be is, you have your tens and your hundreds as your stem, you'd have this as your leaf. So that would equal 323. Okay. So it's important to provide a key when drawing up stem plots, as the plots may be used to display correlative data. So that's why we want to have the data. Ordered stem plots are drawn in ascending order. Now, something to be really conscious of though, is if you've got, say we're using this key here, but you've got numbers ranging from, say, 11 to 55, you'd need to go 1, 2, 3, 4, 5. But if you don't have any numbers in 30, guess what? So you'd say you had 1, 2, 3, 4, 5, 6, but I had none in 30. I just leave it. I've got to have the 3 there, but I just leave it empty. Okay? And you have something like that. That's all you need to do for there. All right. So here's an example. Prepare an ordered stem plot for each of the following sets of data. We've got a big bunch of data there. What I want you to give a go of is in A, is provide the key. Think about what the key would be before I show it to you, okay? And I want you to think about the key for for B as well, all right? So, as we can see, this is the key. We've said that the 12, so the hundreds and the tens, that's your stem, and your unit number is your leaf. And you write it out like that. It's just reading it across from the top 120. So 1, 2, so you've gone from 120, you look across, that's your smallest number you've got in 120, because you found 121, so that's your smallest. Then you look for what's the next biggest, the biggest one. So I've got 40, 140, 120, 140, 160, 150, 170. So therefore, 170, if I keep going across, I find that 117, as in this bit here, represents 170. That is that's where I go up to. Then I just put the numbers down. So I go 9, and then I find a 5. I can put that down. What you need to do after that is order it. You notice that difference? You've gone in ascending order. So I've gone from smallest to biggest. Again, I've changed it smallest to biggest. If it's already smallest to biggest, you don't need to make that change, okay? And the same for in this case the decimal one. In this case, this is representing the decimal point. This is your unit, and this is your tenths. Okay. So if we've got 0.8, we put a 0 where the stem is. Our line is representing the decimal point. Then we just go, so it's 0.8, 0.7, etc. Again, we need to make sure they're in ascending order. So that's been changed. That's now in ascending order. That's now in ascending order, and the rest I don't need to touch. Okay, this is what we want to use something called a back-to-back stem plot. Okay, So ages of the male and female groups using a 10-pin bowling center are listed. We've got our examples here. Okay, we want to do it as a back-to-back stem plot. Then we comment on the distribution. We do the same thing. So basically what we're doing, I'll show an example here. Our stem is the same. So you'd have to be really careful looking at the stem. In this case, our key is 1 with the line, then 5 equals 15. So we're starting at, so we look across and we see it, they're in the tens. We find that. We've got to make sure we find the biggest number. In this case, it's going to be in the 60s. So that's why we've gone down to 6 down here. Okay. And then it's just a matter of looking for the numbers. So we go for males. So on this side, we just look at going, and so we say in the tens, we go 15, 15, cross them out as you do them. There's a 16, so we're going to put a 6, then a 6, then a 6, then a 7, etc., etc., etc. Follow it through for both of them. Okay, and of course, once you've got that, you need to make sure that everything's in ascending order. So you're going to end up with something like that as your final answer. Okay, because everything is now in ascending order, so that's now in ascending order. Okay. Pretty sure that one was already, so we didn't have to change it, but that had to be changed. This one had to be changed. Just to change, make sure the order's correct. Same for this one. Same for this one. This one as well. And that was it. Everything else is fine. If you don't have to change it, don't change it. But if it's not in ascending order, make sure you do change it. Now, what you're asked to do now is talk about the distribution. What is the distribution showing us? Okay, so basically what it's saying, the youngest male attending the 10-pin bowling center is 15. We get that information from there. Okay, whereas if you looked at the girls, it'd be 16. So slightly difference. Whereas the oldest is 65 for the males, but it's 60 for the females. So remember, you can get your range from there. Okay, so you can go between 65 minus 15 is 50. So you've got a range of 50. Whereas for the females, you've got a range of from between 60 and 16. Okay, so that would be 44. So there's a difference. You can look at where the most popular ages for the men compared to the females. So for men, it's going to be the teens in their 20s, whereas for the females, it's the 20s and 30s. Okay, so that's the sort of stuff you need to be looking at here. All right, so as this writes here, the advantage of using a stem plot compared to with a group frequency distribution table is that all the original data is retained. You're not getting rid of anything. You can find some of these details quite easily, like the ranges and stuff. You can get mean, median, mode, and the range from these plots. But if we do class intervals, you can't do that. Quickly go through what a pie graph is. I'm not going to go too much into this. The pie graphs are also called pie charts or sector graphs because they are made up of sectors of a circle. So that's like a sector, 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 etc. Okay. The pie graph shown above has 6 different sectors. The sectors should be ordered from the largest to the smallest in a clockwise fashion. So remember, go in this direction. So we can see that the top 20 in terms of types of CD sold, 40% top 20, 20% alternative, 15 children, 10 dance, 10 country, and 5% classical. Okay. Each sector must be labeled appropriately, either on a graph or using a legend. In this case, this is an example of a legend I was talking about earlier. Okay. I'm not going to go into too much detail on that because there's some stuff that we haven't covered that would, you mean you can do it, but I want you to expose you to what a pie graph actually looks like. Okay, that's it for today. Thank you. Bye.